Good afternoon. Today we are going to learn about errors in the measurement. This is the only topic which is remained from the discussion from this chapter. So let us discuss about it. We all know that physics is all about measurement. So in physics we every time ask question while studying theory. We need to perform, we need to give proof to that theory by performing experiment. So while performing experiment, we need to take different observations, and during this observation, while taking these observations, there include some of the errors. Errors, what is meant by error? Error is a shortcoming which is or uncertainty which occurred in the measurement of that particular read. Okay, so let us take a very simple example of it. Suppose I will ask you distance between two cities. For example, here in Pune, in the class I am teaching, and I am asking you, tell me the distance of my home which is situated in Solapur. So what you will tentatively do is that you will measure the distance between Pune and Solapur, and you will tell me the answer to this question. It is around 200 kilometer is the distance. More specifically, if you will be asked a question that tell me the distance of my home from Pune. So you will measure the distance between station of Solapur to my home, and it comes out to be 209 kilometer. Now more specifically, you will ask me a question. I will ask you a question that tell me the room to room distance, that is distance of my bedroom from Pune, from this class. So you will be telling me that the answer is 200.92 kilometer. So if you will observe, these numbers carefully, then which one is the more specific, which one is the more correct or error free answer? So coming to the question, answer to this question is that this is the more exact and accurate answer, because look at these figures. In this case, comparing these two, this much is the error which is included in this reading. Comparing these two readings, this much is the error, or we call it as a tolerance, which is included in the reading. So tolerance that has been every time, if you will look at it, then tolerance that has been decreased, or we can say that errors in the measurement of this distance, it has been decreased. So more accurate answer to this question, that is the distance of my room from Pune, from this class to that room, it is 200.92 kilometer. So by considering, while performing many experiments, there comes out to be errors in the measurement, and by taking into consideration those errors, we do the calculations, and that much tolerance or that much errors they are allowed. So how much is the error allowed? I'll explain one more example. That is, if I will ask a tailor to make my shirt or kurta with the height of 42 centimeter. With the height of 42 centimeter. So tolerance in the measurement of height of kurta in this value is, let us say, plus minus 5. So suppose 0.5. Suppose the tailor has made a kurta with the height 42.5 centimeter, or he has made a kurta with the height of 41.5 centimeter. So in both the cases, we say that this much error in the measurement, that is okay. Suppose if 42 kite has become 42.5 or 41.5, that is okay. But if tailor has made a mistake, instead 42, if he has made a kurta with a height 43.5, then what we need to do? Our tolerance in the measurement of kurti's height, that is 0.5 centimeter, but more than that it is not allowed. So here 1.5 centimeter height of kurta he has made more, so that is not allowed. That tolerance or that error is not allowed. So what we do generally is that we give that kurta for the alteration, isn't it? So for every measurement there is some tolerance, there is some error which is accepted, but beyond certain limit those errors they are not accepted. Then in that case we need to repair them. So let us first of all discuss about it. What are the types of errors? Now during this measurement we all know that there comes a system. System means what? The system consisting of formula that is used for example, velocity of sound, that has to be calculated. Velocity of sound in air, that has to be calculated by using an experiment, resonance tube. So V is equals to 4 into NL mean. This is the formula. Suppose there is error in the measurement of length, or if a experimenter he is having some vision defect, then he read instead 512 frequency, he read 502 hertz frequency, then that much error it will be included in the measurement of frequency too. So due to formula, sometimes due to instrument. For example, let us consider milliammeter, and 0 of that milliammeter before starting current through it, if it is not coinciding with the 0, that is it is somewhere ahead or below the reference line, then suppose this is the 0 of milliammeter and pointer of milliammeter it is showing somewhere below it before starting current through it, or suppose it is having, this is what called as a negative error, or sometimes if it is showing this much, this error, that is some 2-3 divisions ahead of it, then in that case there comes out to be a positive 0 error. Okay, so in that case, this due to the instrument, due to this formula, or we also call it as a technique, or due to some person. For example, while observing the parallax, or suppose one measurement that has to be done, measurement of one liquid, and the mark is up to this mark we have to fill the liquid, but the observer is somewhere observing that reading below this line, then he may see he may feel that the level of liquid which is above this, and then he will decrease it. Or sometimes if the eye of observer is somewhere here, then the level is below the reference mark, and he make measurement mistake in the measurement of this particular liquid, which has to be measured very carefully up to this reference mark. So due to this person, so these are person, instrument, or technique, formula, they all are the part of system. So due to system, there comes the error which is in picture, they are called as systematic error. it is called as systematic error. The errors which occur due to system, they are called as systematic error. Okay. And another error, in this case, in the case of systematic error, we every time know the cause. We every time know the cause by which these errors are occurred. So the cause is known, and the things which are involved during performance of the experiment, they are called as a systematic errors. But those errors, their cause is not determined, the cause is unknown completely. So in that type of errors, that is called as, this is first type of error. And another error whose cause is not known, those errors are called as random errors. So in this case, these errors, these uncertainties in the measurement, they can be decreased up to certain extent, but it cannot be minimized permanently, completely for some cases. For example, let us discuss one by one. So first type, that is what called as the error which are occurred due to the instrument. So instrumental error. Instrumental error, these errors are occurred due to the faulty or defective instrument. They are called as instrumental error. So how we can minimize this instrumental error? For example, this case of milliammeter, where the zero is not coinciding with the pointer is not coinciding with the zero of milliammeter before starting current through it. It may be positive or negative type of error. So that if you check the instrument before starting your experiment, then in that case you either can replace this particular instrument, or you can fix this pointer in such a way that so it will coincide with the exactly with the zero of milliammeter. Therefore, if this is done, then instrumental error that can be removed from the measurement. Okay. So instrumental error, formula or technique. Suppose you use wrong formula for the measurement of any particular instrument, then in that case that technical or that error in the measurement of that particular experiment, that can be determined, that can be minimized. So formula, if it is wrong, if you are asked to find v is equals to 4 into nl velocity, to find velocity by using this formula, and you are using v is equals to 4n by l. Okay. So in that case, wrong formula, that definitely affect on your reading. You will never get correct reading. So in that case, if you check before making the calculation, if you check this formula, then this technical error that can be minimized. Another error which is called as a personal error, just like I said that parallax which is involved in the measurement of this particular range of a liquid. If this parallax that has been removed, if you change the experimenter, or if you show error of that person who is performing experiment, if you show it to him, then that this mistake that you are doing for the measurement of this particular thing, or any other measurement. For example, if some person is asked to perform some experiment based on optics and he is having vision defect, then in that case he will not give us correct readings. So by changing the experiment, the error can be removed. Or but these errors, if their causes are known, so systematic errors, minimization of systematic error, that is very easy. Now second type of error, which is called as a random error. These random errors which are occurred due to some unknown reason, and they are beyond our control. For example, you are asked to So, for example, if you are asked to perform some experiment under the controlled atmospheric condition, that is, if you, for example, this V is equals to 4NL wala formula, V is equals to 4N into L. By using this formula, you measured the velocity of sound by using resonance tube. You have performed this experiment in winter and you have performed this experiment in summer. So both the readings that definitely get affected, because temperature is affecting on the velocity of sound, and that control of temperature, that is not in your hand, so that cannot be controlled. Or for example, there is one experiment which is there in 12th standard syllabus under short experiment, which is Melday's experiment. So in case of Melday's experiment, in case of this Melday's experiment, there need to find the frequency of AC, and frequency of AC we all know that 50 Hertz, but sometimes you are getting the answer as 52 Hertz, or sometimes you are getting answer as 48 Hertz. By considering the errors in the measurement, we make it allowed this measurement, but we all know that actual value of frequency of this, and this is happen due to what, the sudden fluctuations that is happening in the measurement of this movement of this sinusoidal waves. So this frequency of AC that cannot be controlled. So sometimes you will get this value, sometimes you will get this value. So how you minimize this error? By the principle of probability. What you do in that case, where the causes are unknown, in case of random error, you don't know the cause of particular error. So as causes are unknown, you cannot find the root cause of it, and or where the exactly error and how to minimize, you don't know. So we make a use of probability here. So in case of identification of random error, or minimization of, not identification, minimization of this random error, we make a use of principle of probability. What it says that you need to take large number of group of reading. So as per principle of probability, half of the readings, suppose you have taken 100 readings, out of that 50 are positive errors and 50 are negative error. So if you sum it up and find its average, then automatically the negative part of the error, negative errors, that has been minimized. Or for example, random error, how it occurs, the examples I am giving you. Another example is that, suppose in case of simple pendulum experiment, you are asked to find the time period of simple pendulum. So in that case, what you do is that, simple pendulum, as it is performing experiment and you have started a stopwatch. So what is necessary and sufficient condition? The instant when you the instant when you stop the start oscillations of this bob, when the bob is released, then immediately you need to start the stopwatch. So these two things, if experimenter miss to do simultaneously, immediately, then you will definitely find error in the measurement of time period. Or else another error that can be occurred in this case is that you need to start counting the time period when your bob is either reached to this extrema, or some number of oscillations that has to be, the bob has to perform. Suppose 10 oscillations we need to measure, and the time period for 10 oscillation if we want to measure, then this movement of bob of simple pendulum, that is taking place so fast that when you started counting it, and the moment when it reached to the mean position, little bit ahead of this mean position, what you do in that case is that you immediately stop the stopwatch, and you assume that as a total 10 oscillations. So instead of 10 it is 9, and at a 9.5 oscillation only you have counted the time period. So in this case this kind of errors that can be occurred, and they cannot minimized uh, properly, because we don't know root cause of occurring these errors. So this the minimization that can be done for these random errors, that is with the help of probability principle. So principle of probability, it helps us to minimize random errors. Alright. So these are the different types of error. So let me revise it once again. Systematic, there are two types of errors: systematic errors and random error. Systematic error, we know a cause of these systematic error, but in case of random error we don't know its cause. Systematic error, they are due to the system, they are due to instrument, they are due to technique, they are due to person. So they can be rectified and minimized, but random errors, they cannot be rectified because as I told you, stated in first point, that the cause is unknown, so we cannot rectify it. As the cause in case of systematic error, if it is known, therefore we can fix them up. But in case of random error, we don't know cause, so we cannot fix them up by immediately by changing, just like we did it in case of systematic error, by changing the instrument, by changing the experimenter or something like that. So how a random errors that can be minimized, that is with the help of principle of probability. Okay. And systematic error, either they are positive or negative, it is known. Look at this example. But in this case, we don't know whether the random error, whether it is positive or negative. We don't know the type of random error. So it may be positive, it may be negative. Okay. So thank you so much. This is what the introductory part of the types of error in the measurement. Now we actually will do the calculation of these errors in the measurement next time. Thank you.